strategy. Good. So the first question to myself is descending order. The second question I ask myself is their greatest common factor. The third question is, do I have to factor out -1? If the leading coefficient is negative, yes. Yes. If the leading coefficient, sorry about that. How do I turn this off? My God. Okay, I think I did. If the leading coefficient is negative. Question number 4, what is it? Meaning the responses can be binomial, trinomial, polynomial. Since we are starting with the binomial, that's our first step. Let's say it is a binomial. Step number 5 for binomials. Is it a special product? And this is it. So whenever we are given a binomial to factor, we only have these 5 steps. That's it. I have to ask myself if it's in descending order. If not, I have to rearrange it. I have to factor out the greatest common factor. If there is a negative leading coefficient, I also have to factor out -1. Then I ask myself simply what it is. What is it? So I say it's a binomial because that's what we start with. Is it a special product? There are 4 special products, basically 3. Number 1 special product is the one we talked about some time ago. The second special product is this. And the third and the fourth together, a cubed plus b cubed or minus b cubed. This is the entire strategy for factoring binomials. There is nothing else. Now let's analyze these special products and then we look at examples. This one I know from more than a week ago. And I will blindly say a plus b, a minus b. In any order you like. You either write a plus b times a minus b or a minus b times a plus b, it doesn't matter. So this is the difference of squares that we discussed a long time ago. The second one is also easy because the answer here is that this is not factorable. But to be exact, it's not factorable using integers. We can still factor it, but we don't need to do that at this point. So, what do I know so far? That the difference of squares is factorable. And we know the formula for about a week and a half. What do I know next? What have I found out? I found out that the sum of squares is not factorable. So this is the difference of squares. And this is the sum of squares, which is not factorable. Now we have to talk about this. There is a very nice pattern to it. We will learn it and hopefully we'll never forget it. So what is this? This is the sum or difference of cubes. Before we start working on any problem on binomials, we have to identify and learn the pattern for the sum and difference of cubes. It looks or sounds difficult. No, it isn't. We just have to understand the pattern and memorize it. This is not for something you write on your formula sheet. No, if you need to write it on the formula sheet, you're going to have difficulties moving forward. The special products should be remembered forever. Okay, so we are talking about the sum and the difference of cubes now. A cubed plus B cubed. Easy to remember that this factors into a binomial times a trinomial. That's the first thing we need to remember. It's the only one that factors into a binomial times a trinomial. It's not that we have 10 different ones. It's just the only one. Notice here that we have plus. So we deal with a sequence of signs first. If this is plus, then this is plus, and in the middle there is a minus. So first of all, the sequence of signs, plus, plus, minus. What is the other one, the difference? Well, the difference will be minus, minus, and plus. So the first thing we have to establish the sign. Plus, plus, minus, or minus, minus, plus. Okay. The binomial is always easy. It's always a plus b, or a minus b. In other words, what do I cube to get a cubed? What do I cube to get b cubed? The trinomial is also easy. It's the same one with the trinomial that we looked at last time, but easier. It's a squared and b squared. The last one is always positive, and the middle does not need a 2. It's just the product AB. So this is the same with that special product for binomial squared. But there is no 2 in the middle. It's just the product of AB. So a cubed plus b cubed is a plus b times a squared minus ab plus b squared. The one with minus, a cubed minus b cubed, is a minus b, a squared plus ab plus b squared. Again, the sequence of signs, plus, plus, minus, 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 plus. Okay, we are ready now to practice anything about binomials. This is it. That's the entire strategy for binomials. I don't know anything else. I cannot teach you anything else about binomials. This is it. There is nothing else. Good. So I'm going to start with a handout, and then we move on to what we have from Pearson. Okay. Where is my handout? I lost my handout. Oh, I think I just went to a course. Okay. Here it is. So we looked at one of the handouts. Now we're looking at the other one. Now let me share my screen. And here it is under modules, and the top module. Scroll down to those 2 documents. So this is the flow chart, document 2 that I just showed you. And we want to go to the example. Okay, I'm going to start with A. 4z squared minus 25. Okay, and we'll come back to this. Good. So I have to go through the list. The list says descending order, yes. Greatest common factor, no. 4 and 25 don't have a common factor. Is the leading coefficient negative? No, the leading coefficient is 4. It's positive. Now I have to choose. Is it a binomial, trinomial, or polynomial? We haven't discussed these, so it's a binomial. Now finally I'm getting to special products. It's a difference. So it could only be the difference of squares or the difference of cubes. It cannot be the sum of squares or the sum of cubes. It can only be the difference of squares or the difference of cubes. So I have to choose. Now, obviously, this is not a perfect cube. So it cannot be the difference of cubes. It can only be if it works. It doesn't have to be factorable. No polynomial has to be factorable. But if it is, it's definitely the difference of squares. And the difference of squares require same, 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 same. Same first term, same second term, and the only difference is one binomial is positive, the other one is negative. So, what do you think?
2z plus 5, 2z minus 5.
Of course. 2z plus 5, 2z minus 5. How come? The first term squared is this, minus the second term squared is this. Any questions? Any questions on the first problem? Okay, we move on to the next problem. Please stop me. This is not trivial, and I don't expect you to understand it from the get-go, because it's not trivial. Okay, we're gonna work on all of these, but let's jump to f, x squared plus 16. And we'll come back to the rest, of course. It's in descending order, no greatest common factor, no negative leading coefficient. It's a binomial. And now the question is it a special product? Always remember special products, even if you like them or you don't. Special products are always easier than the rest. So, is this a special product? And here are the special products for binomials. Is this a special product? If it is, say yes, it's that, and you'll tell me how to proceed.
Yes, and it's not factorable.
Exactly. It's the sum of squares. Sum of squares, not factorable. Some books consider it prime. I don't like that, but you can write prime. That's fine. It's acceptable. Good. Okay, so let's continue with x to the fourth minus 81. I have to go through those steps. If you skip any of these steps, you make it more difficult on yourself. So, descending order, yes. Greatest common factor? No. Negative leading coefficient? No. Special product? I always hope for a special product. Always and forever. I hope for a special product. It cannot be the sum of squares. It cannot be the sum of cubes. It can only be, if any, no polynomial has to be factorable. It can only be the difference of squares or the difference of cubes. Anybody? Unbelievable. How do I turn this off? My goodness.
It's x squared plus 9, x squared minus 9.
It's the difference of squares. Indeed, x squared plus 9 and x squared minus 9. Every time we are asked to factor, we are always implicitly asked to completely factor, meaning till no factor can be factored anymore. You will say, oh, but this one cannot be factored because it's a sum of squares. So this one has to stay. But this one can be factored, so we have to continue. So we will continue by writing x squared plus 9 And yes, this is again the difference of squares. And we have to write it as such. So what do I write?
X plus.
Yes?
Oh, you're good.
X plus 3, X minus 3.
X minus 3. Now I can say this is completed. Completed. These are linear factors. Linear factors. Degree 1. This is quadratic factor, which is degree 2. Not factorable anymore, not factorable anymore, not factorable anymore. So we have to make sure that we leave it and move on to the next problem only if everything is fully factored and no special product or anything else can be applied here. And it's done. Good. Let's continue. Let's move on to y to the third plus 8. Y to the third plus 8. Do not ever skip the first steps. Ever, ever, ever. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. What is it? It's a binomial. Okay. I hope for a special product. Because it's a sum of two terms, it can only be the sum of squares or the sum of cubes. If you say it's the sum of squares, then I have to write not factorable or prime. If you say it's the sum of cubes, then you will have to give me a binomial and a trinomial. Yes, it is the sum of cubes. What is the binomial and what is the trinomial? Please, always, always take care of the signs first, please. If this is plus, the binomial has to have plus, and the trinomial has to have minus. Of course, the last term we don't even discuss. The last term in the trinomial is always positive. So we need to identify which term we cube to get y cubed, and which term we cube to get 8. Once we identify the binomial, the trinomial is a piece of cake.
Y plus 2.
Y plus 2. So how do I determine this? I square y, I square 4, and in the middle is just the product. I don't even have to multiply by 2 as we did with the binomial. Squared. The special product for binomials. I don't have to do that because the formula doesn't need it. It's just the product of AB. Any questions? This is not trivial. Calculus students don't know this, many of them. I don't consider this trivial. Okay? Requires thinking, requires understanding of the pattern, requires understanding of the steps. Many students don't understand that these are the mandatory steps. If you skip any of this, you make your life way more difficult. Okay, moving on. Any questions, please? Don't be shy. Okay, we move on to the next one. If you understand factoring now, you're never going to have a difficulty or problems with it. And you'll see how many are struggling because they're not following this structure. If you don't follow the structure, you're all over the place and you may have difficulties. Okay. Descending order? No. So I have to rearrange it. Next question. Greatest common factor? No. Negative leading coefficient? No. What is it? It's a binomial. I know the special products for binomials. There are only two with minus. Either the difference of squares or the difference of cubes. But x to the fourth can never be a cube. So my hope is that I can write a difference of squares. But now we have to think. What term squared is this, and what term squared is this?
X squared plus 1/4 x squared minus 1/4.
Good. Excellent. This is done. Why? Because it's the sum of squares. And we know the sum of squares is not factorable. But this is not done yet. This can be,
Minus 1/4.
so x squared plus 1/4. I'm using the difference of squares again. So then, how do I write that?
The x plus 1/2 x minus 1/2.
Now I can say it's completed. Not factorable anymore, not factorable anymore, not factorable anymore. Linear factors, nothing else. Quadratic factor, but it's a sum of squares. There is nothing else I can do to it.